Welcome to the first day of MAC 132 Blueprint Reading 2. My name is Mr. Geppert, and I wanted to go over real quick what we did today to just give you a reminder about what we learned. What did we learn today? Well, we learned about what you can expect in this course overall. I talked about the syllabus. I talked about the 90-10 grading system that we have. I told you that there were going to be 6 tests and there were going to be quizzes handed out, not quizzes, but homework assignments that would be averaged together. If I don't get the homework assignment back on the due date, your grade will be averaged in as a 0. 10% of your grade is going to be employability 2, which was defined in the syllabus as employable behavior. You show up ready to work and you participate, and your attendance is better than what is required in this course. Okay, I talked about some of my past and the things that you could expect from me. What I'm going to expect from you is a good effort every day to show up and to be able to be prepared enough that if I call on you with a simple question, that you will be able to demonstrate that you have prepared for the class. All right, the course overview I started, which was really the big picture of what we're dealing with here. We are in the business of making good parts quickly. We can't do that if we can't understand blueprints. So to turn that on a positive note, if you can understand a blueprint, if you can quickly see the overall dimensions, if you can ascertain tolerance requirements, if you can understand feature control frames from GD&T, if you can visualize a part in 3D from 2D views, you're going to be well along the way in working on your own. These blueprints are bread and butter. From a big picture standpoint, they are what put food on the table for us. They tell us what our features are to look like and how close they have to be from one part to another and how close in tolerance they have to be in order for them to be assembled. All right? So I also showed you that chapter 9 or unit 9 in your book is very important. You didn't make it to that last time, so I would suggest you reading unit 9 and really getting down on thread measurement. All right, then I talked about GD&T, and I started from a big picture about what symbols are. Symbols enable us to get control of complex ideas. Words are symbols, symbols are symbols. I told everybody that if you saw a red octagon up on the wall with no lettering on it, you would still know that that was a stop sign. Well, it's the same way in GD&T. These symbols were where we're beginning today. And the symbols control the size and features of a part in such a way that we can say that GD&T is a symbolic language used to define and communicate engineering tolerances. All right? It is a great tool for reducing arguments in the shop and for keeping parts from being thrown out because even though they make the tolerances, they still won't fit to what they go to. GD&T came about because our machines just keep getting better and better and better at producing these parts. I use the Mercedes-Benz engine block as the example for that, and getting the tolerances for the cylinder bore sizes down into the millions from part to part to part means an engine is going to last longer. On the other side is the M1 Abrams hydraulic reservoir. They don't need to cut that a beautiful pocket out. It only holds oil, and it has to have a certain volume. Therefore, they don't need to worry about the surface finish or the size of the reservoir to such a degree. So it's dimensioning specifications, and it reduces arguments, And now we only make parts as good as they absolutely have to be. Why? Because we're in the business of making good parts quickly. All right. The last thing was I went over form tolerances in your book. I strongly recommend that you skim this entire chapter, Unit 13, and get a hold on GD&T. I went over the overall symbols. You're going to need to pretty much memorize them. And then I went over into form tolerances, the 4 form tolerances, and showed you how they go from like 2D to 3D. In your book are excellent explanations of what the tolerances mean in a graphic format. You're going to need to spend some time in this. Don't get caught up in the weeds. Whenever you get frustrated, stop and start all over again. And eventually it will sink in. And it needs to, because this is of big time importance to making good parts. Thank you, and we'll see you Wednesday.